G'day, Internet. One of the questions that I get is how to get started with or how to improve on someone's secure code review capability. And usually the answer to that is quite simple, and it's experience. You do something a lot, you tend to improve on it. Now, particularly if you're looking to get started, that might seem like a bit of a catch-22, right? How do you build experience when you haven't started with it? That's fine. I'm going to show us a couple of examples today on some ways in which I improved. In some ways, I still use that if I'm looking to pick up a particular bug class or improve detection for a particular bug class in my tooling, etc. So there's a couple of things. One is pick one language, focus on one language. Pick one bug class, focus on that bug class, and then keep adding more bug classes to it. And don't worry too much about tooling. Ultimately, it is a human operator, even when you run tooling, that determines whether or not something is a false positive or an actual vulnerability. And there's a whole bunch of bug classes that tooling can't detect, but humans can. So let's focus on the human part of secure code review. Our ability to recognize patterns and think logically about things is what makes us so good at this. And this sort of reflects one thing that I spoke about in another talk. I'll link that one down below. And there's a few things that make up your core competencies, I guess, when you're doing code review. So the more bug classes you know, and the better you know the quirks of a particular language, the better you can leverage or recognize when a situation might be exploitable, where other people think it's probably okay. Things, particularly around things like encoding. Then the other ones are system knowledge. It's mostly useful if you're dealing with systems-based programming. There are still things, I guess, in the web that would be equivalent, such as protocols or web service specific knowledge. And creativity. Today, though, we're only focused on one particular thing in the vulnerability and one particular language. Now, I'm going to not pick a particular language, but when you're starting out and when you're improving, it's usually better to get better at one language, and then once you have the understanding and the patterns and the recognition, it's easier to expand to other languages. Right. So what we're going to start with is to look at some code, and ideally you want to look at vulnerable code. Now, you might just go and download a lot of code off the internet and read through it, run tools against it, etc. That's all fine. But I find that in order to really hone in on something, you want to find specific cases of, or specific instances of a vulnerability or a bug class. Now, again, if you're just getting started and you don't have the ability to find that code because you haven't done this before, then you'll learn from others. So you look at other people that have found these vulnerabilities and you apply your knowledge or your logic and your reasoning and your pattern recognition to that. So today we'll look at SQL injection because it's quite standard across lots of different languages. I don't have to get too tricky when I look at a particular piece of code. It'll be mostly recognizable. It doesn't matter if we're looking at PHP, Python, Java, C#. And so we can either look for, say, GitHub issues where it's reported, etc. We're going to work backwards from patches today. So we'll search for places where people have fixed SQL injection. And in order to actually find those things, we we don't need to look at repositories. We need to look at commits. And there are a lot of commits. Essentially, every time you refresh this page, you'll get new findings. So we'll just start by looking at the first one. That's actually, that looks like the same repo. Third one, fourth one, and we'll look at. So we'll open 5. Oh, sorry, I've opened the repository. Probably look at that. Hold on, back up here. Okay, this is Scala. No, Python. Okay, the F. We can see here that it's using a formatted string. And I'll be perfectly honest, this is an encoding style that I'm not familiar with. But it appears that we are changing from a variable being interpolated within the string, which is a formatted string or a templated string. Not entirely sure what the Python terminology is. And it's switching to this, which appears to be a binding or parameterized query. So latest timestamp as a string. See, this first bit here is a string. The second bit doesn't have quotes, so that's the variable. And so that gets, instead of being in the query string, it gets applied as a parameter to the query. So it's a parameterized query. Okay, now there is another step, and that is obviously to determine whether or not the latest timestamp variable is user controlled. So you might have a vulnerable condition or a vulnerability candidate, as it's often referred to, where the code does something that is quote unquote unsafe, but it would still have to be in a call stack with variables that an attacker control in order to exploit it. But we're not going to do further triage now. We're just looking at what this pattern looks like. So we can look at the next one. Okay, that looks like it's the same. It's the same commit. One is the commit, one is the merge. Okay. All right. Well, in that case, we'll add one more. So we look at 5. Okay. So this is the same. We looked at that one. That's the latest timestamp. Photo faces, and again, Python. You see, it's a formatted template string, whatever you call it. Curly brace expansion. And then this time, it's not a named parameter or a bound parameter. It is just a question mark. And we'll see that there are multiple cases in this case in the REST API. Well, so there's the photo, and again, it's moved to the parameterized state, insert. And so you can see very easily from this that it is essentially a pattern. It's cur.execute, and then a formatted string. Second. So to take a step back, this is a quite recognizable pattern. Cur execute, formatted string, citing inside curly braces. Now, obviously, the escaped parentheses here, depending on what the query is, may or may not be present. Let's look at the next one. Again, Python. And I don't believe this. Don't believe this fix is accurate. It looks like the problem is up here. As you can see, we have something inside a, well, that looks like a, it's, let's see. It generates the string and then calls format. And then replaces parentheses with double parentheses. We'll come back and we'll do actual triage later. This one is harder to recognize from just this snippet though. So you might need to look at it in context. We were looking at line 225. So now we can kind of see the similarities. We have cursor execute. Now this isn't a straight up formatted string. It's a, I don't know what you call that, a triple quoted string, which I believe means that you don't have to escape quotes, etc. It may have other things going for it, but again, Python is my strongest thing. Then we call format on it, which is probably similar to format. And then label equals label, so that's that one there. Metadata, it's metadata there, but it runs this through a replace and status. It's not modified, but it appears to be just an enum or a fixed set of values. Could potentially be user controlled. The assumption here, though, is that the metadata is user controlled. And they have tried to fix the SQL injection by preventing this. Now, I'm not going to explain how SQL injection works. There are other places where you can go to learn about this. Let me just detour right now. Probably the best database for different bug classes is MITRE's CWE. And we can search that for injection. And oh, I don't like, I nitpick on CWE, but let's say that we'll look at this one. And again, we can see an example here. This defines a query first, so it just generates a string. And in this case, it's concatenating things into the string, and then it just runs that query. And the idea is that whatever is in here can break out of the quotes, typically by having its own quote. So, or apostrophe. So if the username contains an apostrophe and something else, because that apostrophe occurs before the intended apostrophe, you have broken out of syntax. Most injection vulnerabilities are based around this. I'm not going to explain it. You can look at MITRE for further details. But essentially, it's the same thing here. So it creates this string, and then it will execute that string against the database. And because we have user-controlled data in here, and there are quotes, again, quotes may not matter. So let's look at the next one. And this is Ruby. And I'm assuming that this again is an interpolated value in string. Admittedly, I don't know Ruby at all. And it looks like, though, what looks like that is, yeah, similarly here. So the language details are a little different. In this one, it's not calling an execute, it's calling a join. So it's a different database framework for querying. Most likely this does a select left join. So this might not be a great example, but you can still sort of see, even though you know, you don't know Ruby necessarily, you can kind of see how this happens. I don't know if sanitized SQL will work there. I think. Anyway, I don't know the framework, don't know the language. It looks sort of similar in that you have strings and you have variables, in this case in curly braces, again inside the string. SQL injection seems fun. I'm gonna close that one out. And then let's look at the last one here is PHP. All right. And if you don't know how to look at a diff, I guess I can explain that as well. This bit in red with the minuses, those are lines that have been removed. Green and pluses are lines that have been added. So typically we would look at, yep, here we have it. So this is more similar to the one that we looked at from CWE, where it's concatenating. So it defines a string and then appends the variable as a string, rather than having the variable inside the string. In PHP in particular, you can find both. It doesn't matter. And then again, it runs that straight into the database. Now this obviously, from a language perspective, looks a little different. The concept is the same. You recognize the database query, you recognize a variable. PHP in particular is very easy because you know that the super global get is always user defined. It comes from the URL query string. So very simple example of SQL injection. And I guess I kind of touched on the triage here. Now, depending on how well you know SQL injection and how well you practice it, and I do also recommend that you back up the code review with actually practicing this in labs, where you might just take that bit of code, and because of metadata, maybe this is a function, right? So you just take that whole function, copy it, save it in file, get it to a point where you can run it and supply data to it, and you'll be fine. Typically, the problem with this approach, as opposed to using parameterized queries that we've seen here, well, that's a bound one. This one with the question mark. The problem is that this is insufficient. There are other things. So if we can edit this. Yeah, we can edit. No, can't edit. Okay. Anyway, to cut it short, it's a dictionary, so you can have multiple values in there. Let's go back, 225 there. You can have multiple values in there, and these values can have multiple apostrophes because we see that metadata is a dictionary and it is supplied as an argument. If you wanted to see where that is, you can cross-reference Again, it's not so easy to see in a patch. You see every function that calls this, etc. Again, triage is a little outside of this, but the problem is that if you have a backtick, so an escape character before this, depending on how JSON dumps handles backticks, you might end up with a situation where you have a backtick apostrophe in the final output. And that means you're escaping, and then the secondary apostrophe here. So this first one is considered an escape apostrophe, so it's not part of the syntax. And then you've broken up the double. But again, it would depend on the framework, the database, etc. But one of the reasons why you should often run this, if you're not, like if I'm looking at this and I go, I don't know, I'm not sure, I would run it and I would try to feed it a whole bunch of different data to see. But what I want to show you next is that we have currently learned enough to try to replicate this. And one thing that I've experienced is that when people will fix one SQL injection, they'll often have others. So if we go into this one, we can do select from where ID equals get. And we can see that there are similar patterns, although in this one is parameterized, this one is deparameterized. This one, I want to go have a look at, parameterized. Item files. Item is defined where. So again, I don't necessarily worry about everything that's going on. I'm focused on the candidate and I'm working my way backwards. So we're looking at items for each drive data, and drive comes from row data, and row data comes from this. Okay. So that does not appear to be vulnerable. Okay, so search didn't find much, although we can make it a little bit less restrictive. We look for post. No, that doesn't seem to be the case. And again, I know that I'm looking for post, request, or get simply because I am familiar with the PHP language. This didn't get us. That one looks a little different. Oops. Oh, yep, okay. So here we have if set is files, then a string concatenates files inside an array indicator, and then it calls JSON decode, which will turn this from an array into a series of attributes, and then it appends or ID equals file, and file will be the individual array entries in here, that's concatenated without any escaping, or there's no parameter. Like this should be a parameterized query. This should be a let's see, sorry. Why will it let me? I guess this is part of GitHub's new editor changes. So this should be a question mark, and then there should be appending the values to an array, and then supply the array as bound parameters, or they should do it in a different way where they run individual queries, although that is probably less efficient. So now we've gone from a patch. Go back. So we looked at a patch that they had for an SQL injection. We recognized the pattern, we applied that pattern, and we have found a 0 day in net drivers, whatever this is. Yeah, 3 stars, 5 forks. Most likely just somebody's hobby project, not a big deal. I will still open an issue for this so that they can fix it, and that's it. So that's essentially the basis. You pick one vulnerability class, you look for cases where people have already found it, and then again, what you can do is, rather than look at the patch, you can get the let me go back to this one. Right, so you can get the particular commit number, and you can look for an early commit, check out the code at an early commit, and then see whether or not you can find the SQL injection without looking at the patch even, right? And that's the next step, is without having a pattern presented to you previously, can you just recognize it by looking at the code? And once you're up to a few byte classes, or you also maybe want to practice the exploitation side of it, I recommend moving on to exploit DB, or I mean, you can do both. There's not necessarily that one is better than the other. And so similar, we can look here at SQL injection. And then once we've found some SQL injection, the thing to look for is this one here, where you can download the application. So it has a link to the vulnerable code. And again, without necessarily looking at it, you can just download this, see if you can find the code, see if you can then write the exploit for the code. And if you get stuck, you know that you can go back in here and you can look, and you can kind of, I guess, cheat if you want. Let's see, okay, so this is a post auth. And apparently it just runs SQL map for you. That's yeah, maybe fun. You can still, that's not what. Yeah, so you can still take this approach, but be aware that some of the exploits and exploit DB are of varying quality. Yeah, again, you don't need to look at an exploit to run SQL map. You can just run SQL map. So perhaps maybe a more funnest command injection. So let's say you want to practice command injection. Again, might be hard to get running being a TP link, but you can usually, even if you can't, you can look at what's being done. So it's a post request. See how they are encoding, whether or not encoding is an issue, what they're doing, etc. So it's a good way to learn as well by seeing what other people have done. And that's really all you need to know. Just, go to MITRE, CWE, pick a bug class that you've heard about or you think is interesting. Go to GitHub, search, look for a language that you know, and then just apply those two. Learn a pattern. Sometimes the patterns are just for a particular repo, sometimes they're not. For example, we can actually, before I finish up, instead of doing this, we can take that pattern that I searched for before. And then this is going to be depressing 4 million lines of code. And there you go. This one is parameterized. This one is not parameterized. This one is not parameterized. Ooh, that one is parameterized. That's not parameterized, but cast to an int. That's usually indirect object reference, by the way, whenever you see that. Again, these things come from just practicing. This is what we call taint analysis, where the user input is attributed to a variable, and then that variable is subsequently used in the database query. So you would have to propagate the taint, as in this is untrusted data. Now this untrusted data into here, it ends up in a database query. And this is the concept of source and sink. You can find other videos on that. This was really just a quick one on how you can improve. So I hope that helped. You can try leaving a comment in the below if you have any questions. I can't promise that I'll answer or get to them all. And yeah, good luck and enjoy finding bugs.